Um, yesterday we were talking about these absolute value questions where we had the idea that said if the absolute value of some, I'm just going to write the word expression here, and we'll talk about that in a moment, but some expression was equal to some number, okay, if that was occurring for our particular problem in front of us, then we get two things, okay? We get the ability to solve the expression equal to the number, okay? So what happens is if we start with this red thing, and that's what's happening in front of us, we can get this equation where we just get rid of the absolute value bars, and it's an equation that will be true, okay? Now, the idea is, if you're in a mathematics situation and they provide you symbols, and you just get rid of those symbols and do the work, the question is, well, what were those symbols good for? What was their purpose? And if we could just get rid of them and do the work, do the solving of that equation, there would be no purpose for the absolute value bars. So there has to be some type of payment for that ability to get rid of the absolute value bars. And the payment is that you have to come up with a second equation. The second equation is going to be the expression equal to the number, but what do I do to that number? I change it to the negative version. Okay? Now, this is kind of this is really a really non-mathematical way of writing this. Okay? So what you're going to see a lot of times, guys, is instead of the word expression, they're going to say AX plus B. Okay? And basically all that is that no matter what that expression is, for us right now, we should be able to combine all like terms and get something like 2x plus 5, 10x minus 3, 2x plus 7, something like that, where the coefficient for x is like the 2x or the 3x or something like that, and then the b is the number like plus 7 or plus 5 or minus 10. Does that make sense, everybody? Yeah. So a and b are just going to be numbers, okay? Instead of writing the word number over here, they'll write c. And c just represents some random number. If that is occurring in front of us, if that's what our current problem looks like, then we get this thing here. We get the ability to solve ax plus b is equal to the number, so the expression equal to the number. And then the other one is ax plus b, your expression equal to the opposite of that number. So that is the mathematical way of writing it. Does that make sense? Okay. So you might see that discussed in some manner at some point. So here's the question. Does this, as a specific problem, match, let's go that. Does that match this right here? Yeah, we've got an expression inside the absolute value bars, and the absolute value bars are by themselves. So this here matches this, so then we get two equations. The first equation, you're going to get rid of the absolute value bars, and you get that, right? Yeah. The second equation is the exact same thing, but you make the 13 negative. Can you solve those two individual equations? Okay, so here's the idea, that even though we start off with absolute value, which is something completely new, after applying this rule, you get two equations that come from chapter 2, and we should be able to solve. So, always going to make 2, yes. So we subtract 5. Subtract 5. So we get 2x is equal to, what, 8?
Wait, then you divide by 2x?
And then I'm going to divide by 2, yes. So 13 minus 5 gives me 8. I get 2x now equals 8. Divide both sides by 2, I get x to be 4. Okay. Over here, subtract 5. Subtract 5. That's the same algebra, right? and now I'm down to 2x is equal to negative 18. You divide it here by 2, right? Do the same thing. Divide by 2, divide by 2. So x is negative 9. Okay? Those two things then are going to be the answers that when you plug in right there, you get 13 back. Yes, Evan? Not necessarily. Okay? It just it depends really on the size of that 13. So if that 13 would have been, let's say the 13 would have been like a 2 instead, and I subtract 5 from there, this would be negative 1, right, eventually? And this one would be negative as well. So don't worry whether your answers are going to both be positive, both be negative, because that's not going to be a consistent thing to allow you to kind of know that you're doing things right. Does that make sense? They could both be positive. They could both be negative. One could be positive, one could be negative. It depends on the relationship between the numbers when we start the problem. So here's the thing, guys. When we do this, we get two answers, okay? And most of the time, you guys are probably going to say like x equals 4, and then put a comma, and then negative 9, right? Okay? There are some alternative ways that we like to write answers. If you want to use this, that's fine. I just want to make sure that when we get to Math Excel, and they kind of form fit some of the notation for you to type your answer in, I want you to know what that means. So one way of writing our answers is this. Another way, you might be seeing, have you seen some curly braces?
Yeah.
Okay, they'll put curly braces, okay? And then inside those curly braces, you'll just go type in your answers, okay? And what those curly braces refer to is what we call a set, okay? S-E-T, a set. If I have a set of silverware at home, or a set of china, or a set of coffee mugs, or something like that, what does that mean? If I have a set of silverware, what does that mean I have?
You have all the silverware.
What do you mean all the silverware?
Like, I don't know how to explain it, but you have like a valuable part of. You have all the parts.
I have all the parts. I have knives, I have forks, I have spoons, I have salad forks, I've got all that stuff, right? Yes, forks. I don't think they make silverware sporks. Like metal sporks, do they make those? I don't know. Yeah. They do? Yeah. So we have multiple things, okay? We have a set of things. Whenever we talk about a set, we're usually talking about a collection of things, and they share some characteristics, okay? As a teacher, I have a set of students in my classroom right now, correct? Okay? So people can be a collection of things, okay? Names can be a collection of things, colors, whatever. So a set is just a collection of things. In mathematics, we like to talk about numbers, right? So a collection of numbers. That's one way of writing your answer. Another way, and you might not have seen this in the last lesson, but it will pop up soon, is they write that curly brace, and then they write the letter X, because that's the variable that we're dealing with, right? And then they write this symbol here, and I'll talk about what that means in a moment. And then they write what your X is equal to. X is equal to 4, and then negative 9. And they cover or finish it with a curly brace. And these two things say the same thing. Even these two things say the same thing. These two things say the same thing. Okay? But that last one, the way I read that vertical bar, you guys know what a shorthand is? You've never heard of shorthand?
I think it's on the clock.
This is shorthand. Okay? Shorthand, so like a long time ago, before computers, even before typewriters, if like say a CEO, a president, someone like that would want to have a transcript of a conversation between them and somebody else, they would have their secretary sit in on the conversation, and the secretary would write that conversation down word for word. Now think of it, they don't miss any words. Think about so yeah, somebody a transcriber in court does it. Now they use a typewriter, right? Okay. Well.
Typewriters are overrated.
Okay, so before that technology, they had shorthand, which think about just sitting in this class, and I asked you in the last 10 minutes to write down every single thing that I've said. You can't type that fast, and you surely can't write that fast, right? I might say a long word that you're still spelling out, and now by the time you finish spelling that word out, I am on 6 words beyond that, right? And your mind just can't process that stuff fast enough, and your hand can't write that fast enough that you're going to miss things. So back then, they did, the CEOs, the presidents, whatever, the bankers, they didn't want to have a conversation and have to talk like this so the secretary could write everything. Does that make sense? No. Okay. So the secretaries had to develop what they call shorthand, which is essentially every word had an abbreviation. Okay. And some words and some phrases had symbols instead of the word. Okay. So when they were done with the conversation, really the only person that could read it was the secretary. So the secretary then would go sit down at their desk, and then they would write out the exact wording of that short. They would basically transcribe it, put it into actual words that everybody could read. Does that make sense? Okay. So shorthand was a way for them to quickly take notes on something, and then they would take those notes and then go back and actually finalize it so everybody could read it. This is a mathematical phrase, okay, or a symbol for the word or phrase such that. Okay. There are a lot of that's such that if we draw an upside down A, like the capital A, that means the phrase for all. Okay. This symbol here means therefore. Okay. So there's a lot of that stuff that mathematicians don't want to write the words therefore out. They don't want to write the phrase for all out. Okay. So they come up with this shorthand that was adopted a long time ago. Why is it upside down capital A? I don't know. It's just when somebody started using that, it then caught on, right? Like the first person that started using LOL, okay? It just started to catch on, right? Okay. So you guys have a shorthand language, okay? When you're in English class, are you allowed to use LOL in a paper?
No.
Are you allowed to use UR in a paper? Are you allowed to use U when you talk about YOU? No, because it's not formal, right? Okay. So we like to be, when we're writing papers, we like to be formal, so we don't use that kind of language, okay? In mathematics, we've got shortcuts for that. Like instead of saying UR, YOUARE, a lot of people write UR, right? Letter U, letter R. That's shorthand, okay? So we have those types of things. So in your Math Excel, Web Assign is what I use for another class. They're going to have kind of like bubbles here for your answers, and everything here except for what is in blue will already be written by the author of the question. Does that make sense? And that blue thing will be your box that you get to type in. All you're going to do is type your answers in there, but what I want you to understand is that stuff around it, what it means. And all it means is that I read that, it says X such that X is 4 in -9. Okay? We're just talking, we're telling people what variable I've solved, what variable these answers are going to be representing, what they're for, okay? And then I tell everybody what those answers are. So that notation is important. Now, and the reason I talk about this, in my personal experiences, okay, if you can show me how to do something, I can do it. Okay, you show me some math, a process, and I can understand what's going on kind of in the background, I can do the math. Okay? What I struggle with as a student of math is reading notation. I see something like that for the first time, and it blows my mind because there's no textbook that explains what that is. Okay? A lot of times as you progress through a math textbook, okay, and just math courses in general, they start using notation that they never explain what it is. Okay? And if you don't take the steps to navigate that notation, it's like reading, like anybody in Spanish or sign language or anything like that. Okay, if I'm in those classes, there are some words in probably Spanish that I know just by looking at them, right? Okay, what's the word for pants in Spanish?
Pants.
Isn't it pantalones?
No.
Okay. Okay, so in French it's pantalones. Okay. Okay, so computer is computador. Okay. I could probably look at that and make that argument, right? That I understand that. Okay. Mathematics the same way. There's going to be some things you can look at and say, yeah, I kind of know what they're probably talking about there. But there are things that are completely different that I wouldn't be able to look at and understand just by guessing. Huh?
Spanish don't know the meaning of pants.
Yeah. Who just said that? Oh, pants. With what?
Okay. So when you don't know, so if I don't know the words in Spanish, I'm going to have a hard time progressing through the rest of that course, right? If I don't know the terminology and the essentially the grammar or the language part of mathematics, I'm going to have trouble moving along mathematics and actually doing the operations and those types of things. Okay, so I think it's very important that when we see notation that is different than what we've used, we use it. Okay, what is it? What? Pantalones. So I was right.
No.
Again, Mr. Fay was right. Huh? Okay.
What are you talking about?
What if I do this? What if we let's take this rule again. All right, let's say that we've got the absolute value. Let's go 3x minus 4 plus 7 is equal to, I don't know, 12. Okay? So this is the rule that we have to use, right? Our problem has to look just like that. Does our problem look just like that? No, it does not. Okay? Because this here, think about this. This here, this left-hand side, is only an absolute value thing, right? This left-hand side, does it have absolute value and something else on it? Does that make sense? If these were to match, this would have to have ax plus b in the absolute value, plus then maybe some other number is equal to c. Does that make sense? So this does not match that. So I can't do this yet. So I cannot make two equations. I cannot go 3x minus 4 plus 7 is equal to 12 and 3x minus 4 plus 7 equals negative 12. That would not be true. Does that make sense? Because these two things over here do not match yet. What would I need to do to this left-hand side so that they do match? Subtract 7. So now I have absolute value of 3x minus 4 is equal to 5. Now that thing right there matches that thing right there. Does that make sense to everybody? Okay. If they don't match, you can't get to that part of the theorem yet. Now that they match, I can make two equations. I can say get rid of the absolute value bars, and what you're left with you can solve. And then the second one will be get rid of the absolute value bars, and then take one of those sides and make it negative. Which side makes more sense to make negative? The 5. So add 4 to both sides. So I get 3x is equal to 9, right? So x is 3. Here I'll add 4. I get 3x is equal to negative 1. X then is negative 1/3 when I divide by 3, right?
Yeah.
Okay. Here's my next question. And this is the one we finished on yesterday. What if I go, let's just go 3x plus 5 equals negative 10. Can I do that? Why? Okay, so you're saying right now that this here matches this rule, right? Okay, so let's do this. Let's create our two equations. Let's say 3x plus 5 equals negative 10, right? And the second part is 3x plus 5 equals change one of these sides by a negative, so it'd be positive 10, right? Okay, so you could do that. And what I'm trying to get at here is that nothing that we do is going to show us or come out blatantly say, no, wait, hold on, you can't do that. It's going to allow you to set something up to do some math. If I do this, I get 3x equals negative 15. X then is equal to negative 5, right? Here, I get 3x equals 5, and then x will equal 5/3, right? Okay. Now, let's see if those work. Let's see if those are answers. If I plug in negative 5 here, I get 3 times negative 5 plus 5, and we'll see if that's negative 10. What's 3 times negative 5? Negative 15 plus 5 is negative 10. Okay. Now, here's the question. There were absolute value bars here, right? What do absolute value bars do to a number? Make it positive. So does 10 equal negative 10? Is that a true statement then? No, that's a false statement, right? So that was not an answer. Does that make sense? Is everybody paying attention? That is not an answer. Let's try 5/3. If I plug 5/3 in, what's 3 times 5/3 plus 5? Does that equal negative 10? What's 3 times 5/3? No, times. What happens to the 3? So it's 15 over 3, right? 15 over 3. 15 divided by 3 would be just 5, right? So that 3 and that 3 really cancel out. What's 5 plus 5? 10. What's the absolute value of 10? 10. Does 10 equal negative 10? No. So is that an answer? No. Okay. Now, the only time that I would recognize that those don't work, and those were my only possible answers that would work, but now I've shown that they don't work, there's no solution here, right? Now let's talk about why we could have figured that out at the beginning. This statement right here, if I were to put that into English, it says the distance that 3x plus 5 is away from 0 is negative 10 units. That's exactly what this says in an English phrase. Does that make sense? The distance that 3x plus 5 is away from 0 is negative 10. I don't really care that says 3x plus 5. I'm going to read this. The distance is negative 10 units. Does that make any sense? Distance has to be positive. Every time that I measure something with a tape measure or a ruler or whatever I use, it's always a positive amount. So, yeah, okay. So if I measure my desk from the left-hand side to the right-hand side of it, I'm going to get a number, right? If I measure from the right-hand side to the left-hand side, I should get the exact same number. Okay? So I don't get one of those to be positive, one of those to be negative. Okay? So this idea here, when you have absolute value equal to a negative number, you say no solution. Does that make sense? Now, there's a couple different ways to write no solution. That's one of them. Okay? This is another one, so we use a symbol. Okay? So that means no solution. That's kind of like if you see like no smoking signs, right? They have like a cigarette and then that over top of it, correct? Okay? So that means no, okay? No solution mathematically. There's another way of doing it, and it's to make those curly braces. No, these curly braces. Okay, like we did up here, right? Where's that example go? Like we did here with these curly braces in purple. Okay? But we don't have anything to put in there, right? Inside those curly braces, you usually put your answers. We don't have any answers, so we leave it blank. We don't put anything in there. So that's one way of doing it. Yes?
Are they called brackets?
Braces.
Wait,
Brackets are those. So we call these usually brackets. More specifically, call them square brackets. These we call curly braces. Now, so this is one way. This is one way. This is one way. Okay? These two things are often referred to as what we call the empty set. The empty set. If I were to ask you guys all to leave this classroom, and I ask you how many students are left in my classroom,
The empty set.
it'd be the empty set. If my classroom is a set of students, and then you all leave, my classroom is now empty. Does that make sense? Okay?
You're still
So there's no people in here, so it's the empty set. Okay? Now some people say, well, let's put 0 in here. Okay? Well, what you're telling me that if I put 0 inside those curly braces, you're telling me 0 is a solution. We don't have a solution. We don't have anything that can be put in there. Does that make sense? Okay? The reason I say this stuff is because on your homework, you might go through this and say, oh, no solution. But then they got those bubbles to click. And none of them say no solution, but one of them might say the solution is the empty set. Well, that is the same thing as saying no solution. Does that make sense? So we need to understand that vocabulary and that kind of tie together. So that's if your distance is equal to a negative. What if I do this? Can I say the absolute value of 2x plus 10 is equal to 0? What does that say in English words? But absolute value means the distance something is from 0, right? So 2x plus 10 is my something. So the distance that 2x plus 10 is from 0 is 0. Does that make sense? Can distance be 0?
No.
Why not? The distance you are right now from the position of where you're at right now is 0, right? If I ask you from where you're sitting right now, figure out how far away you are from where you're sitting right now, be 0 units, right? Something can be size 0. So we can do this. We can do this. Okay? So we set up our expression 2x plus 10 equal to 0, and then our second equation will be 2x plus 10 equal to the opposite of 0. But what is the opposite of 0? Okay, well, think about this. Think about how we multiply. When I introduce a negative, I'm just multiplying by negative 1, right?
Yeah.
What's negative 1 times 0? 0. So negative 0 is just 0. Okay? We like to refer so we've got our positive numbers and we've got our negative numbers, right?
Yes.
And we hopefully all agree what those are. We also have 0. 0, determining or depending on when we want to talk about it, we can call 0 a non-negative number. But 0 is also referred to occasionally as a non-positive number. Okay? What does that kind of mean to us? 0 doesn't hold a sign, right? Protons have what kind of charge? Positive. Electrons have a negative. Which ones have no charge? Okay, so the 0 is kind of our neutral. Does that make sense? And in mathematics, there are times that we like to treat 0 as a non-negative number. So non-negative would mean group it with your positives. Sometimes we like to take 0 and group it with our negatives, so we call it non-positive. Okay? Sometimes we like to keep 0 by itself, and it's just neutral. Does that make sense to everybody? Okay, so ultimately through some of the things that we like to do, you can choose what you want your sign to be for 0. But if I do that here, am I going to solve both those equations, just get negative 5 halves, or negative 5 for both of them? Negative 5 for both. So I can do this work. I can have something length of 0. Okay. Does this stuff make sense? Okay, so here's what's going to happen with this. Tomorrow, we're going to take those equal signs out, and we're going to put less than signs in. We're going to put greater than signs in. And we're going to have to approach it with a different perspective. Okay? But in order to do that, we need to know what and or mean to us in inequalities. So we need to understand 3.6. So right now I've got an assignment, and you're working on it for the next 16 minutes. There's an assignment in Math Excel. Part of it is stuff we did in 3.6, which is the and or, graphing, understanding the overlap or the the inclusion of both inequalities for your answer. And then the second half is working with the absolute value equations. Because tomorrow, we're merging them together. Tomorrow, we will use these ideas together and come up with something new. Yes?
Did you do that?
No, I did not do that. Huh? No, it wasn't you, but I'm sure that you were the one that demonstrated to the one that did that how